we will discuss today is ReplicaSet and deployment. So what is ReplicaSet and what is deployment? Why we use ReplicaSet and why we use deployment? What are the main features of deployment and ReplicaSet? And which scenario we can use ReplicaSet and deployment? We will see that in. Okay, now this is what is ReplicaSet. We can use the actual words. What is ReplicaSet? So ReplicaSet, it will ensure that it will ensure that desired number of pods are always up and running. So what it will do here, and it will ensure the desired number of pods are always up and running. I can say desired number of replica pods, I can say, for your understanding. So whatever we mentioned in the replica section, so that defined state, the number of pods will be running. This is what the main intention with the use of ReplicaSet. And what is the purpose? You can say. So why it has to use it instead of ReplicaSet? Why don't we use the deployment? So here, to maintain the high availability, you can say, to maintain the high availability of maintain the high availability of by keeping desired number of pods running at all times. In case if pod fails or deleted, so ReplicaSet will automatically replaces that pod. So this is the main purpose here. And what are the features under ReplicaSet, we can say? So this is mainly declarative. You know what is that mean by declarative? So declarative in the sense, so we can manage via YAML file or with the help of CLI by defining the desired state of that pod. So declarative in the sense, we can manage using YAML syntaxes, YAML file, or with the CLI, command line interface. That is a command line interface. For your understanding, I am writing. Okay, by defining the desired state. Defining the desired state in the sense, so how many pods you want to define with the help of YAML file. So declarative. And what is this? Self-healing. You know what is that mean by self-healing? Self-healing, suppose if the pod fails, how it will be replaced? So with the help of ReplicaSet, it will automatically replaces the pod, deleted pod or failed pod without any manual intervention. This is how that self-healing will reflect. Okay, so RS will replaces the deleted or failed pod automatically without human intervention, I can say. The next one is scalability. So scalability means if suppose if the pod fails, right, and deleted, right, so by default that is replaces the replica set. But scalability in the sense you can up and down without any failures, so you can increase the parts or you can decrease the parts with the help of scalability, with the help of scale command. And that will be you can scale number of parts, you can say number of replica parts up and down easily with the help of scalability. So that is the main feature here. And what are all the key parts and key points we need to remember? So key parts, we can say need to mention this API version. API version was apps v1 and kind was. So key parts I mentioned. Okay, API version, that is the Kubernetes API version which we need to specify, and Kubernetes version, that is apps v1. So v1 I can say, that is Kubernetes version we need to mention. Kubernetes API version, and kind is ReplicaSet. ReplicaSet, the type of object we are trying to create. A small typos you can understood, trying to create. Next, so template here where we can define the pods. So where we can define the pod template, in the sense where we can define our pod. Okay, next one is the selector label. So selector label we need to use with the selector attribute with the match label, so that which pod can select the replica set. So ensure that RS matches the correct pods which is pointing. So these are the key points. And here you can say tip, short tip. So you don't create the RS directly, so with the help of deployment also will create replica set. So here instead of going with the replica set, we can use deployment. Deployment will create the replica set will create the pods which how many pods you are mentioned in the replicas. So I can say you don't want to create a replica set directly, so you can use instead deployment. Okay, which handles updates and rollbacks easily. So this is the replica set. So what are all the purpose, feature, key points and tip I have mentioned. And we'll come to deployment. So when it comes to deployment, I can say deployment. So in deployment, where it can manages the, what is deployment? Where it can manage the replica set. This is the replica set, and make sure that our application run and updated, scaled and roll back easily. So in replica set there is no updates and rollbacks, right? So if the pod fails it will replace us, but there is no suppose if you want to update the newer version of the image in the replica set, so that will not happen with the help of replica set. So that will happen only in the deployment, so it can easily roll back and roll out easily. So that is the main feature and features we can say. So on top of that features, what will come? Declarative, self-healing. This all will come under this self-declarative, self-healing. Along with that, in addition to that, and so rollout and rollbacks, we can say rollout and rollbacks will come. So these are the features with respect to replica set and deployment, where we can use deployment, where we can use replica set, that we will handle it. Suppose it will manage the replica set, rolling updates and rollbacks. Suppose if you want to update the deploy new image, it rollouts to parts gradually without having any manual intervention. This is how it will work. So let's see one example file, the replica set. Okay, replica set definition.yaml file we can see. Okay, here we can mention this API version v1, kind is replica set, metadata, labels, name, or else you can use without any name also. Instead of that we can use metadata name directly for my rs, or else you can use my replica set. And spec you cannot directly mention the containers here. With the help of template you need to mention what we mentioned here. You see that, right? So template is required in the key points, API version, kind, template. Then we'll move on to the selector. Template, under template we need to mention the metadata, the pod section what we discussed, metadata. Under that labels we can say app, I can give you my app. Then spec, here you need to mention the containers pod, containers name nginx container and image was nginx. Okay, the first part is completed. Now we'll move on to the second part, that is replicas. How many pods you want? Okay, that you need to mention in the replicas section. Replicas, CAS. Suppose if I want to two parts, I can mention it as a 2. Then you can use the last one, that is selector label with match labels app, my app, what we defined in our labels data. This one and this one should match. So under the template section, metadata and selector match label should match, otherwise it will not be executed. Okay, and we will see the deployment as well in the here itself. I'm managing the split view. The file is completely same except for the kind. Here we can say deployment. See, there is no change at all. So this is how this is only the deployment file. You can say deployment YAML file, and this is ReplicaSet. So it is replacing this. So you need to catch up this point here. So only we mentioned here in the kind is deployment, remaining portion of all attributes are same, and here this is ReplicaSet. Since I'm making it as a split view, it is giving it as the same. So this is how you can work with that. It is not a deployment, it is deployment. Now we can able to see. Okay, here also it is having the deployment section. So I hope you got it. Now we will try to execute with the help of deployment or ReplicaSet any one file, and we'll see. ReplicaSet, right? Okay, you can copy this, move to the section. So let's here cd. So I'm changing my directory. So here I can say my rs 1.yml I mentioned. Okay, I can paste this code here. So make sure that syntax is always correct, otherwise it will not be working. And okay, so API version ReplicaSet is mentioned as a, you need to mention S as a capital here, ReplicaSet, and my ReplicaSet name, template, labels, spec container, selector, match labels. Okay, then we'll try to execute it, save it, and we can see this cat my rs1.yml file. Okay, now try to create with the help of kubectl create or apply command. So my rs1.yml, my ReplicaSet namespace. Okay, no matches for the kind ReplicaSet in version v1. Suppose it is installed first. Okay, wait a second, any issue. API version ReplicaSet metadata, my ReplicaSet. Okay, that means we are not specifying this apps v1. So keep in mind that if one single letter mismatch also, it will not be executed. Okay, now we'll try to create. Okay, you see this message, my ReplicaSet was created. So how to get the ReplicaSet after creating? So use kubectl get using the ReplicaSet, or you can short name as rs, any one is fine. Okay, so it is having that my ReplicaSet is the name of that ReplicaSet, and the desired pods is 2. Okay, and now we will see how to get the pods. Kubectl get pods. So with the help of my ReplicaSet prefix name, the pods will be created. 2 pods are created. Okay, now so we'll try to create one deployment. Okay, and if you see, if you describe this any one pod, we'll check what content we have given here. ReplicaSet tips, right? Pod. Okay, here you can see this, right? Default scheduler. So earlier we have discussed about which scheduler task is to schedule the nodes, which node it will go. So it is going to the minikube and pulling the image nginx from the Docker hub and successfully pulled this image size with that created container nginx started. This is the events which we can see. Okay, now we'll try to create deployment as well. Okay, cat my rs 1.ml. So you can copy this, we my deploy 1.ml. So we are creating for deployment now. So what we need to change here, only this deployment. Deployment you can say. Okay, save it. We have two parts and we can try to create with the help of kubectl create or apply command -f my deploy rs.ml. So deployment replica set was created. Okay, so we mentioned it as a replica set, that is fine. So we have not changed the name, so it was giving as a replica set only. Kubectl get deploy. See, my replica set deploy was created. 2 by 2 are up and running. So that means you see here kubectl get rs. How many replica set was created? So earlier this one is earlier one, now this is the one which was created. So with the help of deployment prefix and replica set was created. Now you can try to get the pods. See, my replica set 777 pod, that means replica set name. So it is having the prefix name for the pods and it has given some identification for each pod. Two pods was created. This is how you can try to create the pods with the help of deployment, and which scenario you can use deployment and which scenario you can use replica set. You don't want to use the replica set. By default deployment will create the replica set. On top of that replica set will create the pods for your application. So this is how the work procedure, and replication controller it is outdated and they are not using in many organizations now, and only the replica set or deployment. Even replica set also some cases they are using, and not completely, but only the deployment it is using. So it is having the rollbacks and updates as well, and rolling updates, and any if you want to update the new version of the image, and you can use that rollout pods gradually. I hope this will help you to understand the deployment and replica set concept, and make it clear, guys. If you want, you can see this text also. This is absolutely extraordinary notes I have given for you to understand the topic. Yeah, that's all for now. We'll see the later sessions in the upcoming task.